Hey, this is Coach D, and I am about to present a tutorial on how to utilize the TI-Nspire Touchpad Calculator, the 3.2 version, to help you improve your Algebra 1 STAAR EOC test scores. Some of these tips you may use, some you may not. You might want to do some things by hand, but there shouldn't be an excuse that you got a simple question wrong because you didn't check your answer when you have a very high-tech calculator that can help you pass this test on the first try. So pay attention, and here we go. The Algebra 1 EOC is broken down into 5 categories. We're going to focus on one category at a time, so I'm going to break this down into at least 5 segments because I don't want the video to be too long. So this first one is on functional relationships. Now before I do anything with my calculator, I want to start off with a new document. So I'll hit the home button up here, and as you see, as I press buttons, they turn red. I want to use a new document because you can use different pages, up to 99 pages in the document. You can go back and forth to problems and use old problems to help you with new ones. So the scratch pad is useful, but I don't use it very often at all. So a new document will be 1. Do I want to save what I have? No, I want a fresh start. So arrow to the no and hit yes. Arrow to the no and hit the click button. Now, don't select what you want until we look at the first problem. So let's go to this first problem. And without even doing anything, I can see I'm given an equation. My answer choices are tables. I'm definitely going to utilize the calculator on this one. So let's go ahead and read it. Which table shows the same relationship as y equals negative x squared plus 3x? So I'm going to highlight that equation because I know that's very important. And then I'm going to underline the word same because that is imperative. As you see, I'm going to use color throughout this whole process because you are allowed to utilize matte pencils, as they call it, color pencils, on the STAAR Algebra 1 EOC. And if you just color everything the same color, it doesn't always help you. So I'm going to try and utilize color with a purpose, as I would expect you to do. So because I have an equation and I'm going to utilize tables, I'm going to want a graph, because the only way for me to pull up a table is to enter a graph and graph it. So I notice right off the back that I have 4 points that all have the same independent, or x, values, -2. So I'm going to use that to eliminate a couple of answer choices. So I will enter the equation, negative x, and the x squared button is by the 4, plus 3x. Make sure that you type a negative when you mean to put a negative for the sign, and you type a minus when you are using the operation of subtraction. They are not the same, and if you get them interchanged, sometimes it means the same thing on the calculator and sometimes it doesn't. So the calculator is going to do what you tell it. If you type it wrong, it's going to give you the right answer to that wrong problem. So utilize the negative and the minus sign appropriately. So I have to hit enter to graph it, and I see it's a parabola that opens down. It's a parabola because there's an x squared. Opens down because that quadratic term was a negative, or had a negative coefficient. So I need the table, and I will hit Control T to pull up a table. I'm looking for when x is a -2, and I don't have any negative values because it automatically starts off when x is 0 and increases. So I'm just going to arrow up 2 spaces till I get to -2, and I can see that it's paired up with a -10 as the output. That lets me know F and G are both incorrect. So I just went from a 25% chance, 1 out of 4, to get this right, down to a 50% chance, 1 out of 2, which just increased my odds tremendously. So I see the next 2 points are the exact same. They're not going to help me. I'm going to look at 1, 2, and 1, 4. Should x be paired with a 2 or a 4 when x is 1? Well, on my table it says it's a 2. I am done with this problem. Now, the only additional information I'm going to show you is if your values in your table were spread further apart, I might want to adjust the parameters of this table. So I'd hit the menu button, 2 for table, and 5 for edit table settings. I could start at a 10, a 5, a negative, whatever, and I can count by 2s, by 5s, by thirds, by halves. You can enter a fraction here and it'll count by that fraction. The other really cool thing you can do is you can select the independent value to be an ask feature, which means if I enter X values, I'm asking the calculator what's the Y value going to be, or the dependent value going to be, and it'll tell you. So I'm not going to show you that yet because that's going to come up in another problem. So let's go on to the next problem. Okay, second problem. Again, without even reading it, I see I have a relation that I'm given, and I have multiple representations as my answer choices. I have a graph, a table, a mapping, and an equation. So I am going to start off by utilizing this information in the problem. So let's go ahead and read it. The graph of the quadratic function h passes through the points negative 432, 3, 4, 514, and 732. Which of the following shows the same relationship as h? Key word there is same, because it could have said which one was different. I'm going to use my highlighter, and I'm going to start off by looking at the independent values, the x values. So I'm going to highlight each x coordinate from that relation. Then I'm going to look at the table, because right off the back I can see, well, something stands out to me. If these are x values I highlighted, why aren't they under the x column? They're all listed under the dependent, that h of x. So I can see right here, these are all flip-flopped. So that's why answer choice C is automatically wrong. Then before utilizing the calculator, I'm going to look at the mapping and see, do the elements of the domain map to the appropriate elements of the range? So negative 4 should pair up with 32. It does. 3 should pair up with 4. 5 with 14. Oops. And 7 with 32. So the mapping appears to be correct. Let me get that out of the way. So it's looking like these are answer choice. But let's verify that the graph and the equation are incorrect. I'm going to utilize two features, 2 pages, a statistics or list and spreadsheet and a data and statistics sheet. So I'm going to start off by inserting a page, and I've started off with the list and spreadsheet, which is 4. And I'm going to take those points that are listed in my relation, and I'm going to stack them up, and then I'm going to enter them how they would have been stacked up. So for column A, those are my independent, the domain, my x values. I have negative 4, 3, 5, and 7. Then arrow to the right and back up. Oops. And pair them with 32, 4, 14, and 32. The fact that I see this 32 twice, that kind of jumps out to me and lets me think this is going to be a quadratic. So to utilize my data and statistics, I have to label these columns. And when you are just using a list and spreadsheet, you don't do that. But for the data and statistics, you must. And I'm going to call the independent values independent. So IND, hit enter, arrow up, and DEP for my dependent. Again, it's in italics. The calculator doesn't register it until I hit enter. Now I've assigned these columns these values. So if I utilize this later in the calculator and I type IND, it has these exact numbers. So you can't use them again. If I want to use independent, I can write out the word independent. I can put INDEP. But whatever you assign here, you can't utilize those again. They are assigned in the calculator. And there are some assigned words in the calculator already, and you can't use those. You'll get an error message if you ever try to utilize those. So I need that data and statistics. Control I, and that would be 5, for data and statistics. Now, what I'm doing is I'm about to make a scatter plot. Everybody in the classroom could have done their list and spreadsheet exactly the same and then have this page look different. It's just as if I took a bunch of rocks or marbles and threw them down and they just landed. What's going to make them all match up is the next part. So I'm going to hit tab, and my cursor jumps to my horizontal axis, the x-axis, which is independent. Arrow down and select independent, and the points are going to adjust just based on the independent values. Then I hit tab again to my vertical axis, y-axis, which is dependent. I'll select that. And now I have a scatter plot that matches up with what this will look like when I graph it. You can clearly see this drops down pretty close to the x-axis. That vertex is going to be down here somewhere. For A, it's hovering up top. That lets me know that's not going to be my answer choice. I can see how far these are spread apart, that's too high up. But I want to verify, does this equation match? So I'm going to hit menu, and I'm going to analyze my graph, which is 4. And I'm going to pick the regression, which is 6. We said it was a quadratic, so we're going to pick quadratic, which is 4. And I'm going to grab this just so you can see it more clearly. It gives me the equation. Y equals x squared minus 3x plus 4. I don't need to say the 1. It's assumed that there's a 1 when I don't see an exponent, a coefficient in front of that quadratic term. The calculator is going to separate a coefficient and have it being multiplied so that you understand that that's a coefficient and you see that negative sign. So it's always going to put plus signs, but it'll put a negative sign for the term if it was negative. So does that look like my answer choice here? Nope, because we just said that's supposed to be a negative 3x. So that's incorrect, and D is our answer choice. Moving on. Okay, we have, for our next problem, we have a graph of an inequality because it's shaded, so I know that's why it's an inequality. And our answer choices are in the form of inequalities. So in order to graph them, I need them in the form of y inequality mx plus b. We're used to seeing y equals mx plus b. Instead of the equals, we have the inequality. So I'm going to write here, just as a note to myself, y, and put a box, mx plus b. Now, this inequality is already good to go, so I don't have to change it. This next one, the x needs to come to the right side of the equation, and the y can't be a negative. So for the x to come to the other side, we would subtract it from both sides, which means it becomes a negative x on this side. So we'll be subtracting x. So that next step would look like this. Negative y is greater than or equal to negative x minus b. To change it to a positive, I would multiply every term of the equation by -1 or divide every term by -1, which can simply be done by switching the sign of each term. But I also have to switch the inequality. So I'm going to flip the signs, flip the inequalities. So this becomes positive y, that becomes negative or equal to positive x plus b. And that is in the correct form that we want. Keep this separate. For the third answer choice, y is positive on the left side, still got to bring that x over. So again, the y stays, the inequality stays, but when the x comes over, we have to subtract it to get it there. It becomes a negative x. And that b was already positive, we leave it alone. We're good on that one. And the final answer choice, all we need to do is switch all the signs by multiplying by -1 or flipping everything so that negative y turns into a positive y. That flips into a greater than or equal to negative x minus b. So now I'm going to go back to my equation. The line goes up from left to right. That means the slope is positive. We shade up. And how can I determine what the inequality should look like when I shade up versus down? Well, when I was tutoring for tax years ago, a student actually showed me a little trick. She said if you get y by itself on the left side, because we read our equations from left to right, then if the equality is a less than or a less than equal to sign, then you try to write the word that tells you which way to shade. You shade down. If the inequality is greater than or has greater than or equal to, you can write the word up, and that tells you which way to shade. So for me to shade up, I need one of these if y is on the left side. When it's on the right, we'll look at it differently, but we got y to be on the right side. So this one, F looks correct, G does not, F does not. So it's between F and J. Our line goes up from left to right, which has a positive slope. This has a negative slope. So our answer choice is F. Now, the purpose of this was to utilize the calculator. How can you show or prove this in the calculator? Well, we'll graph it, which you could have done in the beginning, but again, we were verifying and making sure you understood all that. So I'm going to insert, Control I, another page, and I want to be a graph, and I'm going to graph this inequality. How do I do that? Do not use the inequality up here. You want to actually delete the equal sign and choose. It doesn't work the other way. So I want the greater than or equal to, which is 5. And if you notice that f of x changed into a y. That's because this is no longer a function. If I use my vertical line test and try to hold my pencil straight up and down, every point that is in the shade satisfies this inequality. So if I draw a vertical line, I'm touching infinite points because there's tons of points stacked up. So it's going to automatically change it to a y, which is good to know. So I want x, and then instead of plus b, that b value up here was actually a 2. So I'm going to put plus 2. And when I graph it, it looks just like the graph on the paper. Now, the only thing I will tell you also is make sure that you hover your pointer over the line, because when you graph inequalities, for some reason, they always pop up as a solid line, but then when you put your cursor over it, if it was dotted, it'll change. So just make sure that you do that. All right, on to the next. Okay, let me get my highlighter ready. The population of a town is currently 9,000. The function p equals 9,000 plus 8t squared can be used to estimate p, the population of the town, t years from now. Based on this function, which statement is true? So I'm going to use some color to underline a little bit of information. P, the population of the town, and it's t years from now. So they give me the equation. That's the nice thing again. From my answer choices, is my population increasing at a constant rate? Well, right off the bat, I see, let me use my pen. I see x squared. That's quadratic. That already lets me know it's not going to be constant. It's either going to increase and decrease or decrease and then increase. So that's not going to work out. Giving me a specific number to look for, I can do that in a table. So I'll utilize that in a minute. The population of the town increases by a specific amount in 2 years. Again, I can utilize the table. And then the town will increase and then decrease. Okay, well, we just said earlier, since it's quadratic, it's going to either increase then decrease or vice versa. So let's go ahead and graph this. So again, I'm going to insert a new graph. And my equation is y equals 9,000 plus 8t squared. But I will not type a t, I have to type an x. Whenever you're graphing, change all those independent quantities to x's. That's the only way it works. Now, did I make a mistake? I don't see my graph. Now, I didn't make a mistake. I just can't see because this positive 9,000 is my y-intercept. So I need to zoom so I can fit what I need into my window. So I'll hit menu, 4 for window zoom, and then A is zoom fit. And it just puts all the important things in your window. You can zoom out, look for the axes if you want. But I can see clearly when I go from left to right, I decrease and then I increase. Therefore, this is not right. That is the opposite. So I need to look at my table. How do I get a table? Control T. And in 2 years, I go from 9,000 to 9,032. That is incorrect. It is an increase of 32. Let's verify that I'm going to get to 10,000 between 11 and 12 years. Arrow down till you get to 11 and 12. I don't need to change my table settings, and clearly 10,000 is somewhere between those two numbers. G is my answer choice. Last one, I think. Okay, a dishwasher at a restaurant is loaded with the same number of dishes every time it's used. The table below shows the total number of dishes washed as a function of the number of times the dishwasher is used. Based on this data, we want to figure out the total number of dishes that have been washed when the dishwasher is used 9 times. After 9 times, the total number of dishes washed. Okay? Well, let's see that this is linear or quadratic. Let's verify. So, my change of x is increasing at a constant rate of 2 each time. My change of y is increasing at a constant rate of 52 each time. Okay? So that lets me know this is linear for sure. Okay, well, I'm going to go ahead and put this in the calculator utilizing my list and spreadsheets to get an equation. And once I have an equation, I can pull a table. So, control, insert, list and spreadsheet again, which is 4. Enter those values, all the x values are independent first. 2, 4. Now I'm going to stop there simply because I know it's linear. How many points determine a line? 2. So I'm not going to enter everything. And on the dependent side, 52 and 104. Arrow to the left only to eliminate one step on the next screen. So I'm going to hit menu. 4 for statistics, 1 for stat calculation. And this is a linear equation, so I'm going to pick 3 for linear regression. If I didn't arrow to the left, I would have had the cell under column B highlighted, so this would have been a B. That's all that saved me from having to do. So, oops, tab down. I want B, control, open parentheses, because in blue those are brackets. This just says I want all my x values to come from column A and my y values to come from column B. I can have them come from whatever column of my spreadsheet. And then f of 3 just means this equation is going to be stored in the calculator as f of 3 whenever I want to use it. I can tab or use my touchpad until I get to OK and click it. So now, the slope is 26. The y-intercept is 0. Don't worry about this. It has nothing to do with what we're doing. Nothing to do with what we're doing. And I want to graph it because I want to pull a table and I want to see the value for 9. So how do I graph it? Sorry. Control I, and I want to graph. And this says F4. If I just up arrow, it's got the equation. 26x plus 0. Hit enter. Control T from a table. And I want to go to 9, so scroll down. And 9 is at 234. So I'm going to write that over here. Okay. So it is a positive 234. I don't need a decimal. If I did, I could put it right there, but I don't need it. Make sure that you bubble in dark. I have seen too many times where someone does this. That's just lazy, and that's going to get the machine to not give you credit. So make sure you do that properly. If the value wasn't that close, let's say they asked me for 90, okay, I'm not going to scroll down to 90. That's when I would go to menu and table and go to my table settings, and I'd say start at 90, and then I would see that value. Okay, so that is the end of the released questions that I wanted to go through for the calculator that have to deal with category 1. Hopefully this was helpful for you, and I have 4 more categories and lots of questions, so practice these, pause them, and go through the calculator steps as you need, and get ready for category 2. Thanks.